Hi friends, in today's lesson we're going to be graphing absolute value functions and describing how they translate or how they move if we think about comparing them to the parent function, which is the absolute value of x. First, I want to start by addressing our formula. So with these examples that we're taking a look at today, our value for a, or that coefficient that's being multiplied by the absolute value, for each of these examples is going to be 1. So that means our absolute value functions are all going to graph as these perfect V shapes, where the right side of our absolute value function has a slope of 1, while the left side of our absolute value function has a slope of -1. While our focus today is going to be on these specific values, our value of h and our value of k. In our absolute value functions, we can see what our vertex is going to be, because whatever number is plugged in here for h is our x value for the vertex, while this constant outside of the absolute value bars is our y value for the vertex. Let's start by taking a look at example 1, where we have the equation y equals the absolute value of x minus 3 in the absolute value bars, and then we have a constant outside plus 2. Because we see inside the absolute value bars, we're subtracting 3, but our formula for absolute value functions has a minus sign in it. That means our x value for the vertex is positive 3, so that way we still see the subtraction sign in our equation. And then our y value for the vertex is that constant that's outside, and it'll always be exactly the same. So since we see plus 2 outside of the absolute value, that means our y value for the vertex is positive 2. So our vertex is at 3, 2. I'm going to go ahead and plot that on our coordinate plane. And if you take a look at this function inside your TI-84 calculator, you'll see that you have the 0.32 on your table. And because our value for a is not a factor for us today, and our value for a is just positive 1, then we have that perfect V shape to just be able to construct the rest of this function. Since our value for a is 1, I'm going to stop saying that now because it's going to be the same for every single one of these examples. Then if we think about what our parent function looks like, y equals the absolute value of x, and that means that our graph has only changed by translating. It has only moved its position on the graph. And because our vertex is 3, 2, that means our graph has shifted or translated 3 units right and 2 units up. For example 2, we have the function y equals the absolute value of x minus 1 inside the absolute value bars with a constant minus 4 outside of the absolute value bars. So when I go to identify my vertex, whatever I see inside the absolute value bars, I'm going to switch the sign. So my x value for the vertex, or h, is 1, and my y value for the vertex is exactly what that constant is outside the absolute value bars. So our y value for the vertex is -4. I can go ahead and plot this on my coordinate plane and then add additional points to construct the rest of this graph. And when we think about the changes that have happened to this function, if we compare that to our parent function, then our vertex tells us everything we need to know. Our graph has moved 1 unit right, while also moving 4 units down. For our third example, we have y equals the absolute value of x plus 2 inside the absolute value bars with a constant positive 1 outside the absolute value bars. Because we see positive 2 inside the absolute value bars, we have to remember to switch the sign so that we know our x value for the vertex is going to be -2. Keep in mind our formula for absolute value functions has x minus h inside the bars, which is why we have to switch the sign we see when we're stating the x value for the vertex. Our y value for the vertex matches our constant that's outside the bars, which is +1. So we can go ahead and plot our vertex and then plot the additional points to construct this absolute value function. Now that that's all done, we can go ahead and describe how our graph has translated. And our graph has moved or shifted 2 units to the left, while also shifting 1 unit up. For our last example, we have the function y equals the absolute value of x plus 1 inside the bars, -3, which is the constant outside of the absolute value bars. Again, when stating our vertex, whatever we see inside the bars, we have to go ahead and switch that sign. So the x value for my vertex is -1, while the y value for my vertex matches that constant of -3. We can go ahead and plot that on the coordinate plane, and then plot additional points with a slope of +1 on the right, a slope of -1 on the left to complete our graph. And now we can more easily determine the translation that occurred on this graph, where our parent function to this new function has moved 1 unit left and 3 units down. That's it for this lesson. I hope you found this helpful, and I'll see you around next time.